Chapter 17 Development of the Human Eye. Page number 644. Development of iris. The normal development of the iris depends on complete closure of the embryonic fissure and is associated with the formation of the anterior portion of the tunica vasculosa lentis. The vascular channels of this embryonic structure originally arise at about the 6th week of gestation, when the embryo length is around 17 to 18 mm, as blind outgrowths from the annular vessels that encircles the rim of the optic cup, and they extend into the mesenchymal cells, covering the anterior surface of the lens. This mesenchymal tissue represents the second wave of neural crest cells that migrated into the developing anterior chamber and ultimately will be incorporated into the iris stroma. Vasculature. The long posterior ciliary arteries in the nasal and temporal regions of the ciliary body bifurcate, and the resulting branches join the vessels at the periphery of the tunica vasculosa lentis to form the major arterial circle. Later, the major arterial circle also receives branches from the plexus of the anterior ciliary arteries. Vascular loops from both the long posterior ciliary arteries and the major arterial circle supply the pupillary membrane, which replaces the most anterior region of the tunica vasculosa lentis. After the ciliary folds, the prospective ciliary processes have formed at the end of the 3rd month. Both walls of the optic cup at its margin grow forward rapidly. At the 48 to 50 mm stage, the growth of the optic cup separates the thick peripheral region of the tunica vasculosa lentis from the vessels of the pupillary membrane. By the end of the 4th month, therefore, the vascular system of the developing iris is arranged into 2 layers: vessels of the tunica vasculosa lentis posteriorly and vessels of the iridopupillary membrane anteriorly. Later, during the 5th month, branches from the long ciliary arteries reach the mesenchyme in the mid-region of the iris. The long ciliary arteries also supply several other branches to the developing iris, to the pupillary membrane superficially, to the stroma, and subsequently the sphincter muscle, and to the ciliary region. The rete of the stroma. The mesenchymal tissue. The mesenchymal tissue of the iris differentiates earlier than that of the neuroectoderm. At the anterior surface bordering the anterior chamber, the cells align with each other to form the anterior border layer. However, no junction complexes develop. Large intercellular gaps remain between adjacent cells, which develop long, tenuous cytoplasmic processes. Late in gestation, pigmented cells come to lie beneath the anterior border layer. Some mesenchymal cells in the developing stroma become fibroblast-like and secrete collagen fibrils as well as other components of the extracellular matrix. Sphincter and dilator muscles. Further growth and differentiation of the 2 neuroectodermal layers of the optic cup involves the development of the sphincter and dilator muscles. Basal infoldings in the anterior layer of the epithelium, which is a forward extension of the retinal pigment epithelium, and a reduction in melanogenesis, mark the beginning of the formation of the sphincter muscle. By 3rd month of gestation, fine fibrils are already apparent in the basal anterior region of the cells. The cells secrete basal laminar material, and during the 5th month, Synthesized myofibrils. The peripheral limit of the muscle is demarcated by an anterior extension of the pigmented epithelial layer into the stroma, the von Michaels spur. Except for the region of the pupillary edge, the muscle bundles become separated from their origin by invading connective tissue septi and blood vessels during the 6th month of gestation. Although structural changes such as development of interdigitations linked by junctions indicate establishment of cell-to-cell conduction in the 7th month, the muscle does not come to life free in the posterior stroma until the 8th month. The first evidence for the development of the dilator muscle is not apparent until the 6th month, when fine fibrils differentiate in the anterior region of the pigmented epithelial cells just peripheral to von Michaels spur. Fibril development gradually proceeds towards the root of the iris. The cytoplasm on the anterior basal surface extends into the stroma to accommodate the accumulating myofibrils, and the nuclei and pigment granules are displaced apically towards the posterior layer of epithelium. The partially differentiated myoepithelial cells continue to develop after birth, but the dilator muscle, unlike the sphincter muscle, is not invaded by connective tissue and vessels and does not separate completely from the epithelium. Pigmented epithelium. The posterior layer of epithelium covered by its basal lamina is a continuation of the non-pigmented layer of the ciliary body and subsequently of the neuroectoderm that forms the neural retina. Beginning at midterm, the cells gradually become pigmented, a process which commences at the pupillary margin, proceeds toward the periphery and ceases at the root of the iris. Pigmentation is complete by the end of the 7th month. By this time, the surfaces of the posterior epithelial cells that border the posterior chamber have also developed infoldings. During development, the adhesion between the neuroepithelial layers of the iris is tenuous, especially at the pupillary margin. In this region, a dilatation known as the marginal sinus of von Zille can often be recognized. However, this separation is considered to be an artifact. The collarette. The development of the collarette in the iris stroma is related to the arteriovenous loops of pupillary membrane that are arranged over the sphincter muscle. Starting in the central region, the pupillary portion of the tunica vasculosa lentis regresses during the 6th month. During this process, blood flow ceases and the vessel walls of the loops constrict and atrophy. The regression continues as far as the peripupillary region of the iris. The remains of the vessels and fibroblasts that cover the membrane are phagocytosed by macrophages that invade the tissue. An incomplete arteriovenous anastomosis, the laser circle, forms at the ciliary end of the sphincter muscle. This demarcates the collarette. By the 9th month, the superficial vessels central to the collarette have atrophied, and the laser circle is established as the venous pathway for blood draining from the superficial vessels of the peripheral iris stroma. The iris is not developed fully at birth. The collarette is closer to the pupil than in the adult. The stroma is thin and much of the extracellular framework still has to be laid down. Figure 17.41. Diagrammatic representation of the vasculature of the embryonic eye at approximately 6 weeks of gestation. So you can see here annular vessels which are coming from the long ciliary artery and choroidal plexus, and then you can see here anastomosis between the choroid and annular veins at the periphery of tunica vasculosa lentis. Then there is a choroidal plexus. Then posteriorly there are varicose veins on nasal and temporal sides. Then there is capsulopupillary vein. The choroidal layer is shown. Then you can see external hyaloid branch and long ciliary artery posteriorly, its origin, almost where it originates. Now, figure 17.42, section through the angular region of a human fetal eye at 15 weeks of gestation, the anterior layer of epithelium at the optic curve margin, OCM, optic curve margin, shows a reduction in pigmentation which marks the genesis of the sphincter muscle of the future iris. TA stands for enlarge of the tubercular meshwork. Enlarge means primitive tissue. Primitive means embryonic tissue. Enlarge means a collection of primitive tissue that is enlarged. So TA stands for enlarge of the tubercular meshwork at the apex of the angle recess shown by arrow. CE means corneal endothelium here. CF stands for ciliary folds. This is the light micrograph. Original magnification is 430 times. Now figure 17.43, regression of the pupillary portion of the tunica vasculosa lentis A at 24 weeks of gestation, loss of the connections between the blood vessels in the central region marks the beginning of the reabsorption. B, by 31 weeks of gestation, few vascular channels remain. This is the light micrograph of flat preparations, the original magnification of which is 40 times. Thank you.